This skill will be looking at using Venn diagrams and two-way tables. This can be found in the chapter topic of Essential Assessment. Venn diagrams, named after the famous mathematician John Venn in the 1800s. He invented the diagram to showcase how to put two variables that overlap with each other. It's a very simple diagram, but it can be utilized really well and showcase information that we just can't show via writing information down. It gets a bit too confusing. For now, we're just going to look at two-way tables and then Venn diagrams afterwards. This question here is taken from the question 1, straight from the worksheet on Essential Assessment. And the question says, what is the probability that a person chosen at random does not own a dog? Right here, we have what's called a two-way table. And a survey was conducted on a certain amount of people, which we don't know yet. What we do know is that a person or a group lies in one of four categories. They either own a cat and own a dog in this category here. They own a cat, but they don't own a dog in this category here. They own a dog, but they don't own a cat in this category here. Or they don't own a cat nor a dog, and they lie in this category here. So you can belong into one of four different categories. Either you have a cat, you have a dog, you have both, or you have none. And the question says, what is the person chosen at random does not own a dog? Does not own a dog. Now, it's intuitively misleading. It's easy to think, oh, okay, it does not own a dog, has to belong to this category here, 17. But does not own a dog also includes the category here, because I can not own a dog and own a cat, or I can not own a dog and also not own a cat either. So it belongs to these two. Okay? But before we get to this, we need to figure out the total amount, because in order to get the probability of a certain event, we need the total amount on the bottom and a favorable on the top. Okay, the favorable we can work out, it's just adding those two here, the 17 and the 15, but the total, we have to add all of these numbers up because we need to see how many people were surveyed. So in this case, we have 12 plus 17 plus 23 plus 15. And that gives us a total amount of 67. The next thing we want to do is make sure we figure out how many people don't own a dog. And that's just 17 plus 15, and that's 32. So our fraction is 32, or probability is 32 over 67. Just in case, let's just make sure that this can't be simplified. No, 32 over 67 is the probability. So in this case, 32 over 67 is our solution. I'm trying to circle it, but it's not letting me. There we go. I have to do it just putting it above this layer here. 32 over 67. To put some context, let's just times this by 100. This is approximately 47.76%. So approximately 47% of, or 48, I'll round up, 48% of people do not own a dog from this total amount here. The next question, what is the probability that a student chosen at random catches the train and catches a bus? So here we got, again, two-way table. We got either a person that catches a bus and catches a train, catches a bus, does not catch a train, catches a train but does not catch a bus, or does not catch neither of them. Okay, 4 different categories, and we're trying to look for catches a train and catches a bus. In this case, there's only one circumstance where this happens. catches a train, and catches a bus, because you have to belong to both categories. So it's this number here. So our favorable one is the 18. So this is the number that goes on top. And on the bottom is just our total, which we just got to manually work out. 18 plus 26 plus 17 plus 13. And that gives me a total of 74. Now I've just realized that 18 over 74, because both of these numbers are even, it does simplify down to 9 over 37. However, all the answers provided are out of 74. So in this case, it has to belong to 18 out of 74. The next question is saying that a survey has been conducted on studying and a voluntary work. If a person from the group is chosen at random, what is the probability that they will be a retired or studying? Grammatically, that does not make sense. I think it should say that they will be retired or studying. Let's have a look at this question. I had to reread the question again. Okay, it is a grammatical error. What is the probability that they will be retired or studying? You can't be a retired. That doesn't make sense. So you can be a retired person, but you can't be just a retired. So let's just assume this says a retired person or studying. So right here, we've got quite a few cells within this table. Okay, what we're used to from the previous questions is just seeing this two-way part here. Because this is the part that how the information about the two different subcategories. But right now we've got an extra bit that shows us the total. And in honesty, this makes the question easier to attempt because it's given us a total amount of people surveyed. So instead of having to add all of these numbers up like we did in the previous, it's given the total amount of people that were surveyed here. And this total is 40. So right now, there is a bit of investigating that we have to do because we have to figure out the different cells that belongs to a person retired or studying, okay? So you can either be employed or retired. So you can either have a job or not have a job. From those people that do have a job that are employed, 5 of them are doing voluntary work. And from the people that are employed and studying, 15 of those people. So all up, there are 20 people that are employed, split up into 2 categories, voluntary work for 5 and 15 for studying. And this also goes for retired, just for different numbers. So retired meaning they've reached the peak of their employment via age, and now they've stopped working. 14 of them are doing voluntary work. And 6 of them, which makes sense to study after you've retired, 6 of them are studying. And what the question is asking for is what is the probability that there will be a retired person or studying? So let's figure out the categories where you're a retired person or you're studying. So from the retired category, you can either be retired and do voluntary work. You can also be retired and be studying. Regardless of what you're doing out of these subcategories, you'll be retired. So in this case here, we have 20 people. All right. So I'll just write this on the top here. So we've got 14, and I've got another 6. And then we also want to figure out who else is studying. Well, we've already got the subcategory of the retired people that are studying, but we also have to include the employed people that are studying too. So this 15 is also included. Once we figure out this total amount, 14 plus 6 plus 15, this will give us 35. We then want to carry this out as a probability. So probability needs to be in the form of a fraction. There's our favorable, okay? We figured out the favorable context, and now we just got to put that over the total, which in this case is 40. So 35 out of 40 is your unsimplified answer. But when you put this into a calculator and have it simplify it for you, it will simplify to 7/8. So 7/8 of these people, 7/8 of these people, here we go, are either retired or studying, or both. Now we stumble across a Venn diagram. And Venn diagrams, how they're read is that there are two categories. Traditionally, there are two. The traditional Venn diagram have two circles that overlap. So there are two subcategories, but you can have more than two circles and it will still be considered a Venn diagram. But this is what we're commonly used to. And from here, we can assume that the question was asked whether you liked jazz or blues, or both, or neither. Okay, so you can belong to one of four categories, and just like the two-way table, you can either solely like jazz, you can either solely like blues, you can like both jazz or blues, or you don't like any of them at all. The question says here, how many people like both jazz and blues? In this case here, we're solely looking for the people that like both jazz and blues. So the amount is 15 because it's where that overlap is. Okay, and we like to associate the word "and" with that intersection here. If the question says what is the probability of choosing a person randomly and them liking both jazz and blues, this will be 15 over the total amount, and the total amount is 13 plus 17 plus 15 plus 10. So that ends up being 13 plus 17, which is 30, plus 10, which is 40, plus another 15, which is 55. So this will be the probability. There's a 15 and 55 chance that picking someone at random will like both jazz and blues. But because this is just asking for how many people, we just need a sole amount of 15. Now the last question, one of the trickier questions that you will see in the essential assessment. And I'm just going to move it to the side a bit because it's quite a big question and I want to make sure it doesn't get cropped out. A group of 40 students were surveyed on their favorite school subject. If 25 students chose English and 29 students chose science as their favorite subject, which is the matching Venn diagram? So what we do know is that 25 students like English. 25 students like English, and I'm assuming they're using the letter E for English, and then 29 for science. Now, it is safe to assume, 25 needs to go on one side, 29 needs to go on the other side, 25, 29, here's my answer. This is not the case. Okay, it's safe to assume that this right here is your go-to answer, but it's not. And the reason why is the question says if 25 students chose English and 29 students chose science, the problem is from those 25 students, we don't know how many of them also like science. And the other way around, if 29 of these students chose science, we don't know of these 29 like English. So there's a bit of an overlap that's going on, but there is a way to figure this out. We know that English, I just put ENG for short, belongs to 29 people. And if we look at this category here for English, regardless of whether they like science or not, all we need to do is add these two amounts up to get our English amount for this Venn diagram here. So for here, English is 15 plus 14, which is 29. Okay, so 15 plus 14 is 29. And how many people like English? Is it 29? No, it's 25, sorry, it's 25. Made a mistake there. It's 25 students. This is 29, so it can't be this one. regardless of what this is, it can't be this one because this is too many. How about this one? 25 plus 14. Well, obviously it can't be. There's an extra 14 people. So that's what? 39. That's 39 people. And we have 25. So it can't be this one. How about 29 and 14? No, it can't be that one either. It's 25 for English. That's gone above by another 4 just on that category alone. So by process of elimination, this must be the answer. But let's just double check. What is 11 plus 14? This is 25. Meaning, we can see here that 25 of these people, regardless of whether they just like English or like English and science, both of them with this overlap, 25 belong to here, which is what we have here. And then 29 students, if this is 14 and this is 15, both of them together is 29 for science, regardless of whether they just like science or both of them. 29 is in the S category, which is in here. And it does say 29 students. So this has to be the answer. And this concludes using Venn diagrams and two-way tables.